Hello everybody and welcome to our presentation Invisible Ink, where we explore the privacy risks of CSS on the web and also in emails. So just as a brief motivation, most of you are probably annoyed by advertisements and the associated tracking cookies that you get with them for free. And as a result, many of you will probably have something like an ad blocker installed, such as, for example, uBlock Origin. However, there are also measures that you can take as a website if third-party cookies are blocked, also to track users. And this is largely based on JavaScript-based browser fingerprinting. And here, the only real mitigation against this is to fully disable JavaScript by, for example, using the NoScript plugin. And in this talk today, we will explore how the same principles can be achieved with CSS, such that this measure also does not work anymore. And using this, since it's only CSS, it also works inside of email clients. And this is quite interesting because we can build something like this, where we have an email that is designed for Alice, and if that email is leaked to someone else, we can detect this. So here, for example, if Charlie receives this email and opens it, Alice will get a notification. Also, what we can do with this is we can build some hidden phishing emails. So we have emails that look like phishing emails to the actual target audience. So in this case, for example, PowerPoint users, and like benign emails to someone who is, for example, tasked with detecting such emails. And all of this is built on CSS-based browser fingerprinting, which is what we will discuss in the first part of the talk. Then we will go over to email client fingerprinting, where we apply those principles in emails. And lastly, we discuss how this could be useful in practice. So my name is Leon. I'm a PhD student at the CISPA Helmholtz Center for Information Security, and I personally have a focus on browser security.
And my name is Daniel. While typically my focus is a little bit more on the lower level side of things, so CPU security and side channel attacks, that's not our topic for today, but instead today we're talking about browser fingerprinting. And when talking about browser fingerprinting, well, the natural first question to ask is, what is that all about? So the idea here is that we have some tracking entities, and those tracking entities are, for example, the providers of big web servers. And they want to identify the users connecting to their servers. And the idea behind that is that they want to link different sessions together. So if you today, for example, connect to their server and tomorrow you come back again, they want to know that you're still the same user visiting that server. And even more than just that, they also want to know if, for example, tomorrow you use your mobile phone, that you're still the same user just on a different device, but you're the same human being behind that. And well, the second question to ask then is, of course, why do you want to do something like that in the first place? And there are a majority of reasons for that. Well, let's first just assume everyone just has good things in mind. So you can, for example, build risk-based authentication based on that principle. So if you have a user, let's call him Bob for now, tries to connect to his banking server, well, then he also sends along his fingerprint, and that fingerprint can then be used to identify him. And well, the server can then just say, okay, that fingerprint, that actually looks like Bob, everything is fine, and Bob just continues. On the other hand, what happens if Bob gets compromised? In this case, someone else with the same credentials as Bob tries to connect to that server, but sends along a different fingerprint. And now the server can just say, okay, that looks a little bit suspicious to me. That is the correct password, but that doesn't look like Bob. So the server can, for example, just prompt for a second factor here because the login activity looks suspicious. And probably a lot of you have seen something similar like this. It could, for example, look like what we have here. So that's a screenshot where Google alerted you because your login activity looked a little bit suspicious to them. But unfortunately, not everyone in the world has only good things in mind.
As teased before, this could also, for example, be useful for advertisement companies. So the idea here is that the advertisement company keeps track of which fingerprints, for example, had which browsing behavior, and then serves them content based on that. So here, for example, the fingerprint of Alice will be associated based on her past activities with, for example, gaming content. And in that case, they serve her targeted content, in this case, gaming. And what we end up with is a scenario where users end up receiving different content based on their fingerprints. The same principle can obviously also be used in order to obfuscate malicious intent. So here we, for example, have a web server that is hosting malware, And the idea is to only serve the malware to actual victims that you want to infect. So here, Alice is going to that web server, and she looks like a regular benign user, so they serve her the malware. But now if Bob comes along, who is, for example, a law enforcement agency or an automated crawler that is trying to also detect such web servers, then that fingerprint will look different. And based on that, they can, for example, serve him benign content in order to avoid detection.
And well, now that we know why someone wants to fingerprint their users and wants to identify who they are, let's talk a little bit about how does that even work. So, well, when you have a user and that user is connecting to any server, let's say a web server for now, that user sends along a lot of meta information. So, for example, the IP address, so that's just the IP address the user uses to connect to that server, and also a little bit more, like the user agent, if you're connecting to a web server, just identifies your browser and your browser version. And you also, for example, have additional information like language preferences. So what you could do is, that's the very simple variant of fingerprinting, you can just take a look at those information and then say like, okay, that looks like one user to me, and if anything changes here, that's clearly a different user. But the problem there is, for example, if we take this room here, and if everyone now tries to connect to the same server, we all share the same IP address because we're using the same wireless LAN here. On the other hand, probably a lot of us also use similar browsers, like probably a majority here is using Google Chrome or Firefox, and a lot probably share similar language settings. So the problem here is that only has a very low entropy for a tracking entity. And it's even worse than that because it's easy to spoof that, because I can just change my language settings and I suddenly look like a completely different user. So modern tracking looks a little bit different. Here the idea is that, well, the server that you want to connect to just also sends you some JavaScript code. Because JavaScript is nice for a tracking party because JavaScript is executed on the client side. And then you can just compute the fingerprint there by just, well, computing a little bit of stuff and send that fingerprint back to the server. So the important question here is, of course, what do we execute in the first place? How do we get such a more advanced fingerprint? And the idea is typically to just combine a bunch of different techniques to identify then users pretty uniquely in the end. For example, we can take a look at the fonts that are installed in a system. So suppose we have two users, Alice and Bob, and the difference between those two is that Bob actually has Office installed, whereas Alice does not. So if you now just take a look at the list of fonts that Alice has on a system, for example, just normal default stuff, Arial, Comic Sans, and Pacifico, you will see that it actually differs from what Bob has installed on their system. Because Bob has an additional font, in this case, Jill Sans. And the reason behind that is, if you install Microsoft Office on your computer, that will also install along quite some fonts that are Office licensed, and you can just use in their products. But that means, as a tracking entity, if you now, for example, just generate a hash over the list of those fonts, that already looks different between users that have Office and users that do not have Office. On the other hand, let's say those two users also have different operating systems. What you can then also do is just, well, ask them to render some canvas that may look like this. So you have a little bit of text here, you have some emoticons, and you have an absolutely positioned rectangle. And the thing is that if you also do the same on a different user, for example, a user using macOS instead of Linux, well, then you end up with slight differences here. For example, the emoticons that you see here are slightly different. But of course, that's already measurable, so we can use that as an indication for different user here. And also there are quite some other differences here, so the text inside that absolutely positioned rectangle is also slightly different. And I think it's a little bit hard to see on the slides, but those fonts are also a little bit thicker for Bob compared to the fonts for Alice. So if you now take a look at the output of that again, you can just use that as another type of identification for your users. And if you then combine a bunch of that stuff, you will end up with a pretty unique fingerprint for almost every user visiting your system.
So the thing here is that current techniques largely rely on JavaScript. But there are also some contexts where JavaScript is just not available. One prominent example that many of you will probably know is, for example, the Tor browser, where you have different privacy levels that you can choose, and the higher you go, the more restricted scripting languages like JavaScript are. Then there's also the NoScript plugin that I teased earlier, where you can fine granularly control which JavaScript is executed and which is blocked. And interestingly, you also have HTML emails, which are rendered by email clients. And here you don't have JavaScript, but the big question obviously is also, can we also fingerprint here? And if we take a look at the web technologies that we have on the client side, there's also WebAssembly and so on, but that is all attached to the scripting languages like JavaScript. So if you take JavaScript away, what you're basically left with is HTML and also CSS. And HTML looks like this. It's basically the backbone of every website. You have elements on there, and those elements give the website the structure, and you can do things with the elements. So here we, for example, have a button, and we have a text element that contains some text. And on the right side, we see how that is rendered, and that is just the default view as my Chrome browser on my Apple laptop did that, and it just looks very boring. If we want to stylize that and make it a bit more beautiful, we use CSS for that. And here we can, for example, give the button a background images, or we can, for example, change the font of the text and also the color. So here we, for example, use the impact font and give the button a background image with a pattern.
And CSS, or cascading style sheets, without the abbreviation, is actually quite interesting nowadays, because over the years, quite some features were added to that language that you can also abuse for fingerprinting. For example, just to introduce some features here, you can have built-in functions in CSS like the calc function, which allows you to have an expression like you can see on the slide, where you just take the screen width of the user and just subtract 20 pixels out of that. And exactly those arithmetic expressions will come in handy later on during this talk. On the other hand, you can also have conditionals here. So-called add rules, so everything that starts with an add character in the beginning, so in this case an add media query, that just only applies a style if the minimum screen width of your user is at least 720 pixels. So if your screen is smaller than that, you will just see a white button. If your screen is bigger than that, you just get a red button. And why is that useful if you're a web developer? Well, you can do, for example, something like this, where you just fetch different images based on the screen dimensions of your end-user system. Because you want your website to look beautiful on every end-user's device, not only on desktop PCs, but also on mobile phones, for example. And if now a computer with a big screen width connects to your system, well, then you just fetch the large PNG image. Versus if a mobile device connects, well, then you just fetch the smaller one. And one very interesting thing here to note is that depending on your screen width, you now conditionally fetch different resources from that server. So if you control the server that those resources are fetched from, you also learn something about the screen width of your users. So you'll learn whether or not the screen is at least 720 pixels in size.
Okay, so now we have the necessary background in order to get into fingerprinting with CSS. And here we first take a look at add rules, since that is basically the conditional built into CSS and directly what we want. And here Daniel already introduced you to add media. And the top one is the one you've already seen, where you can, for example, query the screen width. And you can do that quite accurately by, for example, doing repeated of those. And then you can also do something like, for example, query the user preferences, for example, regarding the color mode. For example, if you prefer the dark mode or the light mode. And in addition, what you can also do is you can query if it is a touch device or not by taking a look at if hovering, for example, on that device is supported. So to summarize the capabilities of this add rule, you get a bunch of different device information that is largely related to the screen and also some user preferences. Then you also have add supports, the add supports rule. And what this does, it basically looks like this, and you have a CSS feature inside of that. And this rule allows you to determine if a CSS feature is supported. And this is quite interesting because on the one hand, you can, for example, check what type of browser someone is using. So here, this -mods property, for example, is only available in Firefox-based browsers. And not only do you get the type of browser, but you also quite accurately get the version, since those features are not all implemented at once, but you get increasing feature support with increasing versions. Then there's also a relatively new addition to the CSS standard, the add container rule. And this looks quite similar to the add media rule, so you also take a look at some width here, and you measure that against 400 pixels. And this is quite similar to add media, but you do not get the entire screen size, but you get the size of a specific container element. And what that is used for, like it's supposed to, is you have elements that style themselves depending on their size. So you only modify the size and the element looks different. So here, for example, the small element is white in the background, and the bigger you make it, once you cross those 400 pixels, you change the background and, for example, also increase the font size. So how is that useful for us, since we want to use this regular feature for something a bit more interesting? And what we have here is a width measurement primitive. And width measurements are very interesting in the context of browser fingerprinting, since we can, for example, detect the language settings that someone has. So here we have the two file picker elements, once in English and once in German. And the German version is just a bit more verbose. And this is something that we can measure by taking a look at the width. And this is actually quite unique for most languages, since you can also scale that and make it measurable basically for arbitrary languages. Then you can also take a look at browser and operating system combinations. So for example, on macOS and on Windows, the browsers look a bit different with respect to the default elements, since they want to match the look and feel of the rest of the user interface. And this is again something that we can measure if the proportions differ. And since we teased font fingerprinting at the beginning, this is also something we can do using the container rule, because if we apply a font to, for example, this text element here, it will have a different width depending on whether or not a font is available or not. So here at the top, we have the impact font, and at the bottom, we have the Montserrat font, and the availability basically determines the width of that element. And container rules are also not done yet, because the idea is to not only make this relative to the size of an element, so the width and height, but to also include arbitrary style queries, so that you can, for example, check if an element has a different color or something. And depending on whether or not that is actually implemented, this might allow even more interesting fingerprinting, especially with respect to browser extensions in the future.
And the thing is that our story doesn't even end here. So there are a lot of features from modern CSS that you can abuse for something like this. For example, also the built-in function that we briefly introduced earlier. So, for example, take a look at the following arithmetic expression here. So, well, if you want to get the result out of that, there is an easy and a hard way. The hard way, of course, is just do the math in your head. But there's also an easy way to that. Well, just take out your browser and, well, execute that code. And if you, for example, have Google Chrome, you execute that, you just get back 0. And if now everyone in the audience is doing exactly that, well, some of you may have Firefox. And if you execute the exact same code on Firefox, you end up with a slightly different value here. So that gives you a primitive to, based on the result of that query, differentiate those two browsers from each other. And the reason why that even works, because, I mean, it's math, right? It shouldn't always result in the same thing. But the reason behind that are approximations of, for example, the sine curve here, the pi function, and rounding of floating points. And if you just use a different query, it looks a little bit shorter this time, but it also behaves in a weird way. You can, for example, differentiate different hardwares from each other. So this time, we just take the same browser, but once on an Intel machine, and we get back the value 13, and once on an ARM machine. So for example, a modern MacBook, and we actually get a slight rounding error here. So based on the value that comes back from this calc expression, we can already tell you which hardware you have and which browser you're actually using.
All right, and let's get into some even more customizable behavior called plugin detection. And what I mean by plugins is basically anything that customizes your browsing experience. So here you, for example, have browser extensions like NoScript and also ad blockers and so on, but also something like Google Translate, which is built into the Chrome browser as it's shipped. And the interesting thing here is that those can actually modify the content of a website. So if you, for example, use Google Translate to translate a website, what it's effectively doing is it's taking all HTML elements, taking the text out of that, and it's replacing it with the translation. And this modifies the content. And if you, for example, now have a website where a video is playing and you enable NoScript, then that same video will be replaced by a placeholder element. And since this modifies the structure of the website, this is something that you can detect using only CSS. And if you, for example, now have Google Translate and you have an English website where you have the term cybersecurity on there, that has a width of 13 characters. But if you translate that now to, for example, Chinese, you only get a width of 4 characters. So not only, depending on the width, do you know that there was translation going on, but the target languages that you translate to are also very unique with respect to their width, such that you can actually differentiate those target languages as well. So to summarize the capabilities of CSS fingerprints, we can query a bunch of different system information, like for example, what browser and operating system you're using, and also their respective versions. We can get a bunch of hardware information, mostly related to the screen, but also, for example, what architecture you're running on. We get some user information, like for example, what language settings you have, and also what fonts you have installed. And those fonts ultimately also reveal what applications you have installed on your system. And you can also detect certain plugins that modify the content of a website. So to summarize all of this, it works neatly in the browser, and we can largely replace the capabilities of JavaScript.
But the thing is, well, during our research, we were not only interested in just web browsers, but we also thought to ourselves, okay, what about mail clients? Because mail clients, maybe they're also vulnerable. Let's just test that. But before we dive into that, just let's set the scope for that. So if you send an email, and just on a very abstract level, let's say you use your iPhone, you send that email is then transmitted to Apple's mail server. Over a course of different other mail servers, in the end, it is received by the recipient's mail server, let's say Google Mail for now, and your recipient can just query that email from there. And for our research, we did not want to assume that we have any compromised mail servers here, but instead we only thought to ourselves, okay, what can we do by just sending an email? So, well, let's take a look at how an email actually looks like. So modern emails are quite capable of stylizing things, and I assume that most of you have seen that, because if you, for example, get advertisement emails, well, they can include pictures, fancy fonts, colors, all that things. And underneath the hood, well, that's just HTML and CSS again. So we thought to ourselves, okay, if that's HTML and CSS, who is responsible for rendering that? And to answer that question, well, let's think about email clients for a second, because there are different types of email clients. We have webmail clients, so everything that you can just access as a website. We have desktop clients like Mozilla Thunderbird, so everything that you can install as an application on your system. And we, of course, have mobile devices with their mobile clients. And, well, the answer may be surprising here, because how they handle that is actually quite similar. Because for webmail, well, you're already in a browser, so you can just render everything using the engine of your browser, because that's naturally capable of rendering HTML and CSS. So you can just do that. For desktop clients, on the other hand, well, for example, Mozilla Thunderbird, you can do exactly the same thing. You just take a browser engine and use that to render HTML and CSS, and then you don't have to reinvent the wheel here. On the other hand, for mobile clients, well, the story is still the exact same thing. You just use the default engine of your browser that is installed on your operating system. So for iPhones, for example, Apple Mail, you just use the Safari rendering engine. So when we're talking about mail clients, in the end, what we're really talking about are also web browsers again. So we thought to ourselves, okay, if that's an email and we have HTML and CSS here, what about JavaScript? Can we just insert JavaScript there and then we get our JavaScript-based fingerprinting in again? But the unfortunate answer, depending on your perspective, of course, is no, you cannot just execute JavaScript there. Because the full truth is that even though you're using rendering engines of a web browser, you're restricted to a subset of features there. And the reason behind that is that mail providers are actually aware of privacy issues being a thing, so they, for example, also proxy all these meta information across different proxy servers, so you cannot typically not even leak the IP address of someone opening an email. But the interesting thing here is that's not a general answer, because there is no standard dictating how an HTML mail should look like, which features should be supported, and which new features should not be supported. So in theory, every vendor can just do more or less their own thing there.
So then what about email fingerprinting? And in order to answer if a client is fingerprintable, since we are basically already dealing with a browser, we basically only have to check if a certain CSS feature is available to us. So if, for example, an email was not sanitized to no longer have that feature. And in order to exfiltrate the fingerprint, we also need to have remote content loading, since otherwise we just don't get the information on our end. And to answer the first question, if certain CSS features are available, we had a rather big analysis. And here we initially had 21 email clients. To each of them, we sent about 100 test emails to test for the availability of different CSS features. And how all of this behaves and is sanitized is actually quite complex. So we had a bunch of test cases, so 2,100 emails in total that we opened manually on all of these clients. And the client behavior here can actually be categorized into two different categories. So on the one hand, we have very lenient clients, which means that we can do arbitrary CSS stuff inside of them, including, for example, container queries that are very useful for fingerprinting. And on the other hand, we also have a bit more restrictive clients, which doesn't mean that they do not allow fingerprinting. It just means that they don't allow arbitrary CSS. So there is some sanitization going on, and certain features are available while others are not. So what is, for example, almost always available is the add media query. And specifically for Black Hat Asia, we also took a look at some Asian clients. So here we have 163 Mail, Signer Mail, Ali Mail, and QQ Mail, and the story is basically the same. So we have lenient clients, which is QQ Mail and Ali Mail, which also allow container queries, for example, and on the other mail, the other two clients are a bit more restrictive. So to summarize all of this, basically half of all clients allow all fingerprinting techniques. Almost all clients allow at least some fingerprinting technique. So what is, for example, almost always allowed is to query the screen size. And sadly, each client supports a vastly different feature set, making this kind of analysis necessary in the first place.
And well, if you send 2,100 emails across different vendors, across different devices, mobile devices, desktop clients, and webmail, well, you end up sometimes finding things that you didn't even intend to find in the first place. And we wanted to take a short minute here to comment on some of those things that we found quite interesting. So first, let's start with the good things again. Proton Mail. Because for Proton Mail, they actually did a quite good job in protecting their users' privacy. Because what happens there, if you now have a CSS-based fingerprinting email and you send that to Proton Mail's web server, or mail server, well, instead of just directly forwarding that to their users, they unconditionally, that's the important thing here, is fetch all possible resources from wherever they could come from. So given the previous example, for example, you just fetch the large PNG and the small PNG, both to Proton Mail server, then just rewrite the URLs and send the rewritten mail to their end user. Which means that if the Proton Mail user now tries to fetch the resource, instead of fetching that from the attacker server, they will just immediately fetch that from Proton Mail server. So the tracking entity does not learn anything about the user in this case, because unconditionally all the resources were accessed. So that's a good thing. But unfortunately, not all the things that we found were good. For example, on Samsung Mail, you could do something along the lines of this. So you could just add an iframe inside your mail. And in that iframe, you were actually able to execute JavaScript code. And then, well, you had JavaScript code execution by just sending your user an email. We have to say it's not completely the worst thing that could happen because you're still inside an iframe, so things are still a little bit isolated. But of course, you can, again, apply all the JavaScript-based fingerprinting techniques again. We disclosed that to Samsung Mail and were awarded a bug bounty here. Another very interesting example, if you ask us, is the Sogo Mail client. Because for them, they just forgot one corner case for CSS-based injection, which are the add import statements, which allow you to just load additional style sheets to your client. Because if you did that, they forgot the sanitization and isolation between what stylizes a mail and what stylizes the rest of their mail client. Meaning, if you, for example, set the background to purple inside your mail, you will end up with something like this. So your entire mail client is suddenly purple. And that's actually way more severe than it looks like on the first place, because what you can do with something like this, because you can now apply styles to the complete mail client, you can, for example, build something along the lines of this. So you take a look at everything that is called subject, and if the first letter of your subject is an A, you just send a query to your controlled server with exactly this information. If the first letter is a B, you do the same thing there. And now you just reload yourself all over again, and this time you just target the second letter. Then in the end, we were able to extract all these subjects from all the mails that the user could see when just clicking on our email. And we reported that to Sogomail. They awarded a CVE for that, and luckily that bug is now fixed.
All right, so the fun is over. Let's get back to fingerprinting and how email fingerprinting is actually useful. So first, we have to discuss the setup a bit. So here we have Bob, who is the tracking party, and he owns a web server. And he sends an email to Alice, and as we discussed before, that goes via some email servers that we don't necessarily control. And then ultimately what ends up happening is Alice opens the email, and the conditions that are executed on her client are relayed to us, and then we can aggregate a fingerprint on our side. And if we, for example, want to build something like risk-based authentication, we can do this. We can, for example, build something like leak detection. So here Bob sends the email to Alice, and once Alice opens that email, we just check if the fingerprint matches, if it is what we expect. And if, for example, the email was leaked to some other party that will not match, and this is something we can detect, and then we know that there has been a leak. Similarly, we can also do enhanced tracking for advertisement purposes, for example. So here we are just interested in gathering information about a user, or for example, linking different email addresses together. And here we send an email, and we get, for example, the operating system that we are interested in, and we can build a profile of the respective user. So since this is a bit privacy invasive, the natural question is, can we also prevent this as a user? And here, the first thing we can do that we also discussed earlier is we need to exfiltrate that fingerprint somehow. So we can just prevent remote content loading. Similarly, we can also fall back to plain text emails, which just removes the problem entirely. And we can also use a more restrictive client that, for example, doesn't have the powerful features such as container queries. And once you're, for example, at the infrastructure level, you can do something that is similar to what ProtonMail does. And here, the idea is, again, to fetch unconditionally all resources that a user could theoretically load and inline that into the email, so that the user either doesn't load any remote resources anymore or loads them from your trusted server. And if you take an email like this, it could look something like this once you rewrite it. So you just fetch this evil image inside of here, and you rewrite that as a data URL. And that way, the problem is removed entirely, and basically no privacy leakage is going on here.
Well, but the thing is, now let's assume we have a mail client with all these mitigations in place, except the plain text thing for now. So we cannot exfiltrate any information anymore. Hence, the question is, does that solve everything that there is? And the unfortunate answer is, well, we wouldn't have that on these slides if that would be the case. So the answer is no. For example, what you could do is, let's start with the good things again. You could build something to prevent leaking of confidential information. So let's say you write an email that is only visible for someone with the correct fingerprint. And if someone who's not supposed to read that content comes along, you just display either nothing or just some arbitrary other text that looks realistic. Versus if someone comes along with the correct matching fingerprint, well, then you just show the actual secret content of your email. And why that works? Well, because you do not need to fetch anything there. You just, on the client side, take a look at the fingerprint, compute that, and based on that fingerprint, you stylize things differently, in this case, meaning you either show text or alter the text altogether. Of course, if you have such a primitive, so conditionally changing the text of your mail, you can also use that for more malicious stuff. For example, spear phishing. And as mentioned in the beginning of the talk, what you could, for example, craft with that is just an email that looks like a typical phishing email, but if your user print looks a little bit, let's say, different because we're using suddenly a Linux operating system or something that looks a little bit more Well, techie, let's say, like an IT department, we just change the content of the mail altogether, and we just display regular content. So if your IT department now takes a look at the content of that email, it looks completely fine to them. And that, of course, also works because for something like this, we do not need to extract anything. It just works without loading any remote resources. So, of course, we want to also mitigate that type of attacks. And for that, one thing that still works is just get rid of everything fancy that there is in your mail clients. Just only send plain text. That will work. Because some of our vulnerabilities that we nowadays have are just based in the complexity of things. Of course, let's face it, that's not really practical, but you can still use a client that restricts the capabilities of HTML mails. As during our analysis, you've seen that there are different types of clients with different behaviors when it comes to HTML mails, and some of those clients even allow you to configure some of these things. So be a little bit aware of what mail client you're using actually affects your privacy. And if you're, for example, in an IT department and you're tasked with detecting spam emails, just also be aware that if you have a clever attacker, they can also just change the content of your mail depending on, for example, the fingerprint of a user.
Okay, and with that, we are wrapping things up. So what we talked about today were that on the one hand, style sheets alone can be used for very advanced fingerprinting and can largely replace the capabilities of CSS-based fingerprinting. CSS-based fingerprinting, since we're no longer using JavaScript, can also be used in emails, which allows us to build some interesting primitives. And this email fingerprinting is at least difficult to mitigate since there is no single entity that is controlling everything that is going on inside of email clients. And with that, we thank you for your attention, and we are open for questions.
Thank you very much. Very interesting talk. I was wondering whether or not you were aware of any existing phishing campaign which is already using this cloaking technique?
That's a very interesting question. So as of now, we are not aware of any of these fingerprinting techniques being in place in some phishing campaigns, but it's also quite difficult for us to get the data on that actually. So there might be some companies that could look more into this and may have fresher data sets than we have available. But it's definitely something that should be taken into account in the future.
And similarly, could you use that as a way to detect that you have a man in the middle, like an evil NGINX or something like that? That this is what phishing campaigns are using these days, right? You have the client not talking to the end server, but talking to a proxy, evil proxy, that talks to your server. Could you use CSS provided by the server to figure out that it's actually not talking to the end client, but to the evil proxy?
That would be at least difficult, because what the man in the middle could, for example, do is just not render the email. And then the CSS and the remote resources inside of that would not be loaded. So there would be no information that the man in the middle is there from the rendering perspective. And this party can also always just refuse to load remote resources. But what would be possible is to obfuscate an email such that the man in the middle could not easily read it, at least.
Yeah, I think we can do more, but yeah, let's talk after.
Okay, yeah, sounds very interesting. Any other questions? If not, we thank you again, and we are open for talking afterwards.